Recording. Yeah, recording has been started. So let's see. You can see my board, right? So let me just check. You can see my board, right? Please confirm. Yep. So let's begin. Uh, I guess you already know what a function is. Okay, so it's a method uh, which is used to write the code like for the simplicity of the programmer. Okay, it's written for the modularity in a code that every particular chunk of code perform a particular function which we know and is defined in function. Okay, and it's used for code reusability, that we don't have to write the same amount of code uh, a lot of time. We just write it once and then use it forever. Okay, so now I am saying that it's used for one more particular thing which is known as recursion. Okay, it's a particular phenomena by which we code the like we by which we code the programs, and it's one of the basic things used to code our programs. Okay, so what a recursion is, it's calling the same function a lot of time. We call the same function from itself a lot of time until we want. Okay, so let's come to the code, then you will be more clear how it's done. Let's suppose we have to find the Fibonacci number f of n. Fib of n. Now we all know the relation. What is the Fibonacci number? It is fib of n minus 1 plus fib of n minus 2. Okay, so one thing, now we will perform this by the help of recursion. Okay, we will calculate the fib of n by the number. So let's write the function. What our function will return, as we know that the Fibonacci number is integer, and what it takes the number n of which we have to calculate. Okay, now every recursion has three basic parts. Base condition, recursive formula, and return statement. Okay, so base condition is what that we know, that has been given to us by our mutual understanding or by the question itself. So let's, in this we know that it's given that Fibonacci of 0 is 0 and Fibonacci of 1 is 1. So now we know that what we can see, that if n is less than 2, then what is the Fibonacci number itself? So it will be a base condition. If n is less than 2, then return this. What is our function is doing? It's coming to this checking the value of n. If it's less than 2, then yeah, I am returning the same function. This is the base condition. Now a recursive formula. Now we know that this is a recursive formula. Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So what will it be? Will be let's say we declare a new variable f. What it will be? F equal to, then how are we calculating Fibonacci of n? We are passing the n to a function named fib. So how we will calculate n minus 1? We will deploy the same method. Okay, and f equal to this and this, Fibonacci of n minus 1, Fibonacci of n minus 2. Okay, so now what we have to return? We have to return the Fibonacci of n, which is stored in what variable? Variable f. So it will be return f. Okay, so for now, don't worry about how Fibonacci of n minus 1 is has been calculated or Fibonacci of n minus 2 has been calculated. Just think of it as a black box. Okay, that uh, it has been given to me that somehow I am getting Fibonacci of n minus 1 by deploying this function. Okay, so it's just consider this as black blocks and don't worry about this. How are we calculating this? Okay, so what it will be equal to some black box plus some black box, and we know that what is in this black blocks? Fibonacci method of Fibonacci of n minus 1 and some method of Fibonacci of n minus 2, how has been calculated. But for writing the function for suppose nth number Fibonacci of n, we don't worry how this has been written or this how Fibonacci of n minus 1 has been calculated, because if we write the if we write the right code for Fibonacci of n, then we already know that n minus 1 has been already implemented. So we just write it as a black box. Don't worry that how it will be calculated and all. Now this is the implementation part. Uh, but you may ask that how is this calculated? Let's start. Okay, let's take the case where n equals to 4. So okay, so let's start from beginner. Okay, let n equals to 1. What what will become here? Fibonacci of n. So Fibonacci of n. Now, what is the base condition? That if n is less than 2, then return n. So what it will return directly? 1. It will not go to the recursive definition or the return statement after this. It will just return 1 here. Now n equals to 2. Fibonacci of 2. Now we note that n is greater than 2. N is greater than equal to 2. So it will, this line will not process. Okay. So now we will go to our recursive definition, which is f equals to Fibonacci of 1 plus Fibonacci of 0. Okay, so now this, what is this? Uh, this is just Fibonacci. Okay. This will call, remember this is a function call, right? Fibonacci of 1. So this will call a function with n equal to 1. Now, as we have seen that it will be called as Fibonacci of 1 and it will return 1 directly. This will also call Fibonacci of 0 and it in turn will return 0. So what we are getting return from the return statement, Fibonacci of 1 is 1, Fibonacci of 0 is 0. So what will be our f? It will be 2. Oh, it will be 1. Okay, it has been done. So now after that, we are going to return statement. What is our return statement? Return f. It will return 1. So it's a general convention to represent the recursions by a tree. So let's see what it is, how this can be implemented as tree. Now we know that we are calling for n equal to 2, right? It is calling for n equal to 1, right? Fibonacci of 1. It is calling for n equal to 0 2, Fibonacci of 0. Now what this does, it just returns. So it, there will be no two divisions, because we don't need this. Our function is just going here and returning, and this also just returns 0. Okay, so let's take the case. Let me check if there is any question. Okay, no question. So let me just proceed to the case when we increase the value of n to 4. Now what 4 will do? Let's do this by the graph only, by the tree only. So by our understanding, we can see that n equal to 4 will call n equal to 3 and n equal to 2, right? Now what will n equal to 3 call? It's greater than equal to 2, so it will go to that part. Okay, it will call n equals to 2 and n equals to 1. Now what will n equal to 2 call? It will call n equal to 1 and n equal to 0. This will give 1, this will give 0, this will give 1. The same will happen here to n equal to 1, n equal to 0. This will return 1, this will return 0. Now you know that like you can see that what our function is doing, right? It's just taking the n equal to 3, calling n equal to 2, then n equal to 3 in turns call n equal to 2 and n equal to 1, which calls this, which, and n equal to 2 calls n equal to 1, n equal to 0. So this just goes on. Okay, so what will be n of n equal to 3? It will be sum of n equal to 2 plus n equal to 1. What is n equal to 2? It is sum of this 2, which is 1. This is already coming to 1. So what it will become? Addition of this 2 will be 2. So this is 1, this is 0. This will be 1. So now n equal to 4 is the summation of these 2, and it will become 3. So this by this process we can just like it calculates the functions indefinitely. Okay, how large the value can be. Okay, now as you can see that for every node, like for every any here, I am calling two more things. Okay, and for every node here I am calling two more. This just goes on. For every node I am calling 2, so it will so that become 1 2 3, then 4 5 6 7. Total number of nodes 8. Total number of nodes 16. Like not this node, the total number of 1 2 3 4 5 6. Okay, so here total number of nodes equals to like 7 15. This just goes on. So like if n equals to 4, then how much nodes were there? It can they were like some 9. Okay, if n equal to 5 will be there, then there will be this much levels and some level here too. So it will become like somewhat uh, okay. So it will become somewhat like 20 something. So now you can see that for every node I am calling the two nodes more. So for n equal to 4, how many nodes are there? Approximately like 8. Here too there are 16. For every node I am calling two nodes, so it will be 2 to the power n, right? Somewhat 2 to the power n minus 1, anything like that. It will be order of 2 to the power n time complexity, because for every node I am calling two more nodes. So the time complexity of this recursion is 2 to the power n. Okay, so I hope you got this. So let's take another problem. Okay, any doubts till now?
Can you please repeat the time complexity part?
Yeah. So don't focus till like the actual number of nodes right now. Just figure that for every node, I am calling 2 more nodes. Okay, and how much levels are there for n equal to 4? How much level will be there? 4 levels. Okay, so this will just keep on multiplying. Uh, like the number of levels will be approximately same to the input we have already given. So it was n equal to 4, then how much levels? 4 levels. If it equals to n equal to 5, then 5 levels will be there. If n equal to 3, then there will be 3 levels. So how much levels are there? N levels approximately. Okay, approximately no, right? Exact 10 levels, and for every level, I can say that approximately at every level the nodes have been doubling. So uh, uh, for every node, for every level, I am just multiplying the previous level by 2. So it will be just become order of 2, right? 2 to the power n, somewhat like this. Total number of nodes for
Okay.
every level. Yeah. Just move on to uh, recursion part. Now, what is a recursion? Oh, recursion what? Factorial. Factorial of n, we can write it as n to factorial of n minus 1. Okay, this goes on. So now you will tell me. Okay, so like it's a simple example. What is a return variable? Integer. You can just go on in your mind, right? Now, what are our three? How is a recursion represented? It's represented in 3 parts. Base condition. What is a base condition? We know that factorial of 1 equals 1. Okay. What is a recursive condition? F equals to fact of n minus 1 into n. What is the return statement? It is just return. Okay. So this is just simple program of factorial. Okay. Now let's draw the recursion tree of factorial n. N I am calling some node, then n minus 1. Some node like multiplying, I am calling n minus 2. It's n minus 1. Right? It's not a node, it's just a value. So this just goes on till n equal to 1. As when n equal to 1, I'm just returning this statement. I'm not producing any other node. So how many total nodes are there? 1 to n. So how many times a program will run? N number of times. Right, every node represents how much time the program will run. Okay, n number of times. So I hope everyone understood this. It's a simple thing. Now we will come to a difficult question. Okay, so if you don't understand this, don't like, and please ask, because it's a difficult question. I am expecting that you will not understand it in the first go. So what are we trying to do? We are just trying to do find all subsets. Okay, so let's begin. For every subset, I think you have studied the STLs, right? Vector. Yash has taken the classes, right, of the STL. So I am assuming that you know the vectors and all. So I am storing a subset in a vector of int. Okay, because you know that we can't like fix the size of a subset because it is a variable. So we can't declare this in an array. So I am declaring it in a variable size function known as vector. Wait. Okay. So and I am declaring all this. I am storing all the subsets in a vector of int. What this vector of int store? It stores all the vectors of vector of int. Let's name this result. Okay. So from a function, like if we are given an array, we can like, okay. So now we have to find all the subsets of this array. So how many subsets it will be? So how many variables are there? 6. So you know that there will be 2 to the power 6 subsets, right? So 64 subsets will be there. Now for every index, I can decide that whether to take this or not. So let's suppose I am at current index I. So I have to decide whether to take this variable in my subset or not. There can be only two cases, right? So I'm just deciding that whether I should take this element or not. And when I am done with this decision, I will just move on to I plus 1. This goes on in I plus 1. I will decide whether I should take this or not. If like when I have taken the decision, I just move on to I plus 2. This goes on till I equal to n, when our array completes, when don't have any element to decide. Okay, so mm, how we will decide? So let's just see that part. What will return? Let's suppose void of subs. uh, I am passing vector of vector in. This I am passing as reference, so you know the value of like the variable remains same. I am passing integer of array. What we have, integer I, idx. Let's divide by idx, and in total number of elements. Okay, so it has been stored in an array. So idx start from 0 and goes till n minus 1. So when this condition will come, if idx equal to n, then what will happen? Uh, we don't have any element to decide whether we should take this in the subset or not. So we'll just return. Like don't go further. Just return from here as you don't have any element to decide. So this is what our base condition. Okay, I am passing initially uh, like from main. I am passing this result a 0 and n as I am beginning from the index 0. Okay, so and what our result has in like initially, if I have not decided any element yet, then in my result vector of vector I have an empty vector which will denote empty subset, right? If I have not taken any element till now, then I will have an empty subset. So how we'll do, we'll have vector of int empty. This is before passing this to this function. Okay, this is just in main. Vector of int empty, and then result dot pushback empty. So when you declare, it's an empty vector, right? So I am just pushing this empty vector into our vector into our subset of, like, set of subset. Okay. So our what our result vector has till now, it it has one empty subset. Okay. So now for every subset, I now have to decide that whether to take this element or not. So for every subset, two choices are there. Okay, take idx, don't take idx. So how we will do, like, for taking idx, I will just push back. Okay, the what array of idx to our subset, all the subsets. And if I don't take idx, then it will just be similar, like previous subset. Like no change will be there in all the subsets. So what I'm doing is I'm making a replica of every subset. Okay. So for every vector in what result. Okay. What I'm doing is, for every vector in result, I am just and like making a copy vector of vector v, copy of ith vector. Like I will run a loop here, right? For I equal to 0 till res dot size, and I like don't res dot size. Okay, I will just give you the implementation. Okay, later I will just like focus on the concept here. Copy of the ith vector. Now we dot push back. What is the element? Array of idx. And what we'll do, we just push back in the result vector. Okay, so uh, how we are doing this, don't take idx. As I've said that there will be no change in our vector if we don't take the idx, so it will be just the similar. And for taking idx, I'm just creating the copy of every subset, and I'm inserting the vector idx element idx to that vector. So I have taken the element idx to my subset. So you understood this, right? If you don't, then ask the questions. It's not easy. Okay, so there's a question around what time. I don't know till now. If you have any doubts regarding this, then please ask. I will show you how. Yeah,
Please, can you please repeat the loop part inside the loop?
yeah. So inside the loop, what I am saying is, I have for every subset. Okay, for every subset in res, what I am doing is I have two choices: take the idx or don't take the idx. Don't take the idx. How I'm handling is, don't do anything to the vector, right? Suppose the our result vector is this right now, and our idx is 3, right? So what I can what do we'll have the initial vector. Okay, whole, and this. Okay, so this will be my final result. If after I have consideration, I've taken the consideration 3. So you can see that it's just a copy of the previous thing. And what I'm doing here new is that for every subset I'm inserting the variable 3, 1 3 2 1 2 3. Okay, so what in the implementation I already have this part. Okay, so don't worry about not taking the 3, worry about taking the 3. So how can I take the 3? And that for every vector I will just push back that value, and I will just, like, for every vector I will create a copy. Okay, so first I create the copy of this empty, then I push back the 3, then I push back this in the result. So this will do this, push back this. Okay, and for every vector I do that. So for 1 also I am just making copy 1, I am pushing 3 into it, and I'm just pushing this into my, like, result vector. For 1 2 I'm doing the same. So let's see how we will implement this in C++. It's not a trivial implementation because we have to
Hello.
consider. Yeah.
Oh, so with there are two loops now for
uh,
like for every vector in res and then that vector inside.
I'm not getting a two loop. Yeah, can you repeat what are you trying to say?
Okay, okay. For every vector in res. Okay, I got that.
Okay, so I already have this part, right, in res. I just have to add this part.
Yeah, I got it.
Okay, so let's see the implementation. So first implementation of man. I will declare vector of vector in result. It will store like all the subsets. Now I'm declaring integer array of n size. Taking I will take the inputs right from the user or define it manually. It's my choice. Then what I'm doing is I'm calling sub of res a 0 as start from 0 and total size n. Then print all vectors of res. This much I'm doing in main. Okay, so it's easy to understand what I'm doing. Now the difficult part is this. Don't forget this reference part. Okay, this just create one copy of res. Otherwise, every time you call the function, it will create a copy, and you will not get the results. Because I want to copy, like as I said that I am already assuming that I have not including part. So yeah, this part one empty one on 1 comma 2, I am assuming that I already have this part. But if I don't do this reference, then I can't make this assumption, because every time I call this function, it will generate a new variable. What is our idx and integer? What I'm doing first, I'm checking the back the base condition. If idx equal to n, then just do return, because you don't have any element to consider. Now uh, as you can see that in the loop, uh, I am pushing back the values to the rest in the loop only, right here. So it every time it increases the value of the size of rest, right? So I can't just write in the loop that for I equal to 0, I less than rest dot size I plus plus, because for every time I am increasing the size of rest. Okay, so it will be like it will not give us the fruitful results. So what I will do, I will just store the size initially. What was my initial set size? So sz equal to res dot size, run loop till for every subset. What I have to do is that make a copy of this subset. This just creates a vector v and copies the elements of res I to this vector v. Okay, it just copies the whole vector. So vector v res of I. Then what I'm doing, v dot pushback a of I dx. Then what I will do is result pushback v, right? Then what we'll do, we'll just call uh, sub of idx I plus 1, right? Because I've considered all the things of the idx and will remain the same. This is the function, right? In the main, I have missed something, so let me just write that. As I have said that if I have not considered any element, then I will have to initialize it to empty subset, right? But I'm not doing this in the present thing. As you can see, what can you see what the problem will be here if I just do this? Now the size of res is 0, right? Because I have not inserted anything in this res. So every time I'm go in this loop for res for this loop, I will not go inside of this loop, right? So I will just be calling empty res every time, because here only I am inserting anything. But if I don't have anything, I can't insert anything. So all the things will run and our res will always be empty, right? I think you got that. Insert like v of int empty res dot pushback empty, and then call this and do the original flow. Okay, any problem in this implementation or logic, anything? I will just move on to the recursion tree then.
Could you explain that rest dot pushback empty? I mean, what does empty store? I couldn't understand that.
Yeah, so if you don't have if you have not considered any element till now, right? So you have empty subset because you have not considered anything, right?
Okay, got it. I understood.
Okay, so then let's move on to the recursion tree. uh, when n equal to 0, what it is doing, then the size is 1, right? It's doing uh, the things of in the rest, uh, how how many times for the size times. So it will run one time, then it goes to n equal to 1. What is the size here? 2. Then it goes to n equal to 2 here. What is the size? 4. For every element I'm considering. N equal to 3. What is the size? 8. So I'm just summing up the things, right? So as you can see, it will be of order of 2 to the power n, right? No, just simple thing, not some like difficult thing or not. So for every element, for every step, I'm just considering uh, till all the res elements, and I'm summing like running the loop till res elements, and then what will total time complexity? It will be sum of all the operations, which is sum of all this. It will come of order of 2 to the power n. Right, I guess, yeah, all of you are clear at this point. So let's take one more problem. It's similar to that this only. Partition problem. What is this problem? That given a set, like how we are defining a set, it's an array of element. Then can you create two sets containing like A and B such that A intersection B is phi? That the these sets don't consider any like don't share any element. A union B is array. Like you have to create two disjoint sets A and B such that every element is in one of these, and that sum of elements of A equals to sum of elements of B. Okay, summation of like sum of elements of A equal to sum of elements of B. So let's just consider one thing: 1, 2, 3, minus 1, and 5. Okay, so 2, 3, right. So now, can we divide this array in this two? So let's suppose A is one count, B is okay. A is this, B is this. Now sum is 8, sum is 8. So yeah, we can divide this in in two sets like this. Uh, as you can see that we have to create subsets only, subsets of a set. So this is related to our previous problem. Now, how do we modify a previous problem? This is up to our hands. Okay. So for every
Hello.
element, yeah,
Actually, the above set, acha, okay, it's -1 or 1, the third element
minus
in
one,
A.
minus one, minus one.
Sorry.
Okay, no problem. So for every element I have two choices: either go in A or go in B. Right. So let's say that initially I have not considered any element, and my variable, let's say, some set equal to 0. Now what I do is that for every element I insert in A, I increase the value of some set. Some set is the very like for some set is all the values, summation of all the values in A. And what is some set? All subtraction of all the values in B, like sum set equal to sum set minus summation of all the values in B. So now what we have to do is initially if I have not considered any element, that is A is empty and B is empty, then sum set equal to 0, right? Because there will be no addition and subtraction operation. When our condition has been fulfilled, that I have mm, done this too, and I am checking whether I have created two sets A and B, and I am checking whether the sum of A equal to sum of B. Then what I can do is that sum set equal to 0, right? If this condition passes, then sum set equal to 0, right? Because A for all the values, like this is sum set plus equal to sum of a, sum set minus equal to sum of b. So if sum a and sum b are equal, then sum set equal to 0. Okay, so for every element I just have to consider whether to add this or subtract this from variable sum set, right? This is the main gist of the problem, like how we are proceeding with the problem. Then we will do the coding part. Once you understand the logic, it will be easy, because if you have understood this subset problem, it's easier than this. Okay, so creating all the subsets, so it will be easy for you once you have created, once you have understood this logic, that how am I proceeding with, like, from previous problem, like creating all subsets. Here also I'm creating all the subsets, right? But I'm checking where, like, how am I checking that sum of a equal to sum of b. One thing you can do is that for creating all the subsets, first create all the subsets, then create, like, calculate the sum of all subsets, then just check whether this any of two are equal. But that will take a lot of time, right? First calculating the subsets, then for every subset I am taking the size of this, like doing the computation of this size of the subset for calculating the sum. Okay, it will be a tedious operation. So if, like, considering all the subsets are of size n, order of n, then total number of subsets is 2 to the power n, then it will be 2 to the power into n, right? So it will be a tedious operation, and then checking that whether two sums are equal or not. So it will be a lengthy solution. So what I'm doing is I'm creating a new variable subset sum set, and just doing the things in the here only. Okay, so let's proceed how we will code this. You can see the similarities, okay, between the previous and this. So what I'm doing is I'm int main for creating a sum set variable, initialize it to 0, right? Because I am not considering it equivalent to empty subsets, right? Empty subset. So I'm, if I am not consider anything, then sum set equal to 0. Okay. Then what I'm doing is like taking the array a of n, uh, check, I'm declaring check equals to uh, pa partition part of what I have to part, array a, and what is my initial index, 0, what is my final index n, then what is my sum set value. It's initially 0, don't have to write sum set and all. So it's initially 0. This is just equivalent to empty, and I'm doing previous, like same like previous. Okay. Check, if check is true, then yeah, I have a partition, else false, and just return. Okay, this is my main function. Now how am I writing the partition? So what our partition will return? It will return boolean variable, right? Boolean of partition, int a, int idx initialized to 0 from here, int 10 size, and int sum set. Okay, so previous, from previous, if idx equal to n. Okay, so from previous what we are doing is that returning the things, right? From previous example, uh, if we have encountered this, that idx equal to, then we were just returning the things, because we can't decide anything. But from here, what you have to do is that when all the subsets, when all the elements have been considered, then I have to check that for the two subsets I have formed, whether the, like, whether the sums are equal or not. Okay, so how am I checking that sums are equal or not? Checking sum set equal to 0. If sum set equal to 0, then what? I have a partition, else return false. I don't have any partition. Okay, if idx is not n, then I have to consider the idx element. Okay, so now how I will consider that? Understand this. So if I like if go to a, then what I will do? Sum set plus a of idx. Okay, so a new variable will be sum set plus idx, and what I will do is that pass this variable to idx plus 1, right? So
Hello.
yeah,
Sorry to interrupt you, but I got this that sum set is sum of all the values in A minus sum of all the values in B.
yeah,
Then why we have used it in main? I didn't got that.
yeah. I was just like this is nothing, just forget this. I'm passing here 0. I was just like clarifying you that this is for empty subset, like for like the previous example. Initially it is 0. Got it?
Okay.
Okay. So if go to a, then sum set equal to sum set plus idx, and then I will just pass this to idx plus 1. Then so what I will and I will check uh, that whether in idx plus 1 I am forming this or not. A comma idx plus 1 and sum set plus a of idx. Checking whether that if I am passing this, then is there any combination of which passes this thing? Okay, and if there is, then my answer will be yes. Okay, if there is any one partition, I will not have to check for every partition. If there exists any one partition, then my assumption is right that I can do this sum set plus idx. If I do sum set plus idx, then I can form this. So check, let's name this as check 1. Okay, and if go to b, then do the same. What will check 2? Sum set minus a of idx. I'm inserting this in b. Okay, so if check 1 is 2 or check 2 is 2, then what I will return true, return false. Okay, if any one of this is true, like if I do sum set plus idx or if I do sum set minus idx, then if anyone is true, then my answer is true, right? Because I have to take any combination. So return true, else false. If both are false, then it's false, that I can't do anything that will give me the answer. Okay. So see the code, uh, that if you understand this or not. I'm initially passing sum set to 0, and for every element I'm checking whether adding this will make me like make the answer true, or whether subtracting this will make my answer true. And I'm checking that whether anyone is making my answer true, and if anyone is, then I'm returning that yeah, I can make my answer true. Then otherwise I can't make anything that will make our answer true. So return false. Okay, so let's take the example. Okay, so of three element array. 1, 3, 176. What is the IDX 0, 1, 2? Initially, I am passing it to n equal to 3, right? And my IDX is 0 initially, and subset is also 0. So for IDX equal to 0, that is this, I will come here. IDX equal to n, no. Then do this. Check one is A, and like A, 2, 3, and IDX like subset plus this one. Check 2 is A, 2, 3, minus 1. Right. Then I go to this. I'm coming here. Then what I can do is that let me make the tree. Okay, it will be more convenient then. Let me just use another page. So what is our array? 176. What is our initial? I am not writing A here, right? A and N. I am just writing two values, IDX and some set. What it will yield? It will yield 1 and 1, 1 and minus 1 for this element. Then it will yield what? 2, and I can add 7 or subtract 7. Here also I can, it is minus 1, right? So I can add 7 or subtract 7. Here too, it's 6, right? So I can add or subtract. 3, 14, 3, 2, 3, 0, 3, minus 12, and same for this. Okay, now if like IDX equal to n is right, n is there, so I'm checking whether the subset equal to 0 or not. So yeah, my subset is 0 here, so here they are false, right? So it will return false. It will also return false. Both are false, so it will return false, right? Now here it's returned 2, it will return false. 1 is true and 1 is false, so it will return 2. Anyone is false, anyone is true, right? It will return true, and this will return. Got it, right? Simple program, right? Anybody have any doubt in this? Okay, so I don't think that there are any doubts till this part. Uh, I hope everyone is clear. If you have any doubt, please ask. Like, it's one of the most important topics in the coding recursion. Okay, anything that can be coded, it can be coded in recursion. So let's take one like something more that something similar to this backtracking. Okay, so backtracking is similar to recursion in that in this backtracking we generate all the possible outcomes. Like backtracking is the special part of the recursion, right? Generate all the possible answers, then check whether anyone is possible. If possible, then return true, else false. So as you can see that our previous two examples of creating all the subsets, like not the previous one, that whether the partition problem uh, is same as backtracking, right? We are generating all the possible subsets which can lead to the answer, and then checking whether anyone is possible, right? I'm generating all the possible cases, and then here after generating all the possible cases, I'm checking whether anyone is possible. So yeah, I got that this is possible by this tree. So what I can see that if it is 3 comma 0, then I can just backtrack, right? So from what step I got 3 comma 0, I got it from 2 comma minus 6. From which step I got 2 comma minus 6, I got it from 1 comma 1. Okay, so I can see that the flow that after adding 1 I got to 1 comma 1, then after adding, like after subtracting minus 7 I got this 2 comma minus 6, then after adding 6 I got this. So what I can infer from this is that my subset was 1 comma 6 and 7. Okay, so from this we can get the orientation, like which are the two subsets after in backtracking. So what I'm doing here is generating all, checking whether anyone is possible, and then what I'm doing, I'm just backtrack the answer that which we have got, and check that this is possible or not. Backtrack the answer. Okay, like check the orientation, like what was the subset or like that, from which I got the correct answer. If answer exists, then backtrack, get the uh, method how we got this possible answer. So one standard problem here is you have been given n cross n chessboard. Here it is 4 comma. Then you have to place queens. So how many maximum possible queens can be placed in this? Uh, can we place 6 queens in this chessboard in any orientation possible? Like you can place any queen at any possible you like, but can we place 6 queens in this chessboard? My answer will be no, right? Because there are only 4 rows, and if we place 6 queens in this, then we'll have to repeat like at least one row will have 2 or more queens, right? We can't accommodate every queen to one row. So some row will have at least 2 queens, and suppose this row and this are the position, then this queen can kill another, and it will be replaced. So we can't place more than 4 queens, right? So we can place maximum of 4 queens in this 4 cross 4 chessboard. So it's generalized for n cross n, maximum n queens, right? Any other orientation is not possible, like more than n queens can't be placed in n cross n chessboard. Okay, so now we have to find the positions where we can place these queens, right? So how to find that? like consider one queen and check for every position. Like I'm considering ith queen. Consider, let's like I place suppose these are the columns, right? So this like the queen placed in first column is named one queen, first queen placed in second column is second queen, third queen, fourth queen. Okay, so I am numbering the queens by the columns. So for every ith queen, consider every like the column is fixed, right? For ith queen, I will place it in ith column, but the row is not decided. I can place the ith queen in any row of this column. So for ith queen, consider every possible row to be placed. Okay, and once I place this, then check whether this row like this place is feasible or not. So just like these subsets that generate all the positions, like if I place one queen here, then I have the choice of two second queen to place here. But you know that I can't place this here second queen because it's in like diagonal contact. So I can place it here or here on this position, uh, third or fourth. Now I will come to third position, third column. Then I can place it in second row or fourth row. But as you can see that both these rows I am in diagonal contact with this queen, so both these rows are not safe. So I will just backtrack that this is not possible. I will have to place it here. If I placed it here, then I can place my third queen in the column third and two, because but you know that second is not in direct contact with queen. So this is my final position till now. Yeah, I have considered three queens. Now I will go to fourth queen. Then I will consider all the positions. That how at every position how can I like any queen can be placed or not. If it can be placed, like here I can't place, here I can't place, here I can't place, because if I place one here, then it will be diagonal contact. I can't place one here too. So there's no position feasible in fourth if I do this orientation. So for every queen, I generate this possible orientations and check whether this is possible or not. This is a difficult problem. I would recommend that like read it from yourself after solving some recursion problems. After you get somewhat idea of how recursion works, and you can code your recursion problems yourself. So then no, then only go to backtracking, because this is a difficult problem. There are optimizations of backtracking too. They are just high level concepts. Don't go into this directly. I'm just giving the introduction of backtracking here. This is just a special part of recursion, right? I'm calculating all these subsets. I'm checking whether any subset is possible. If it is possible, then go upward and see whether like how am I coming to this subset. So it's just this. It's a general specialization of recursion. So go to backtracking after you have somewhat mastery in recursion. Understand the backtracking. It's a wonderful concept. Just see like what a wonderful problem it is, right? Because days and queens in and cross and chessboard such that any queen don't kill anyone. So beautiful question, right? So I go into this after you have completed some questions in recursion. After you think, yeah, you can code somewhat recursion problems and all. So I guess let's end this meeting right now. If you have any question like general questions or related to what we have discussed in this lecture, anything you can ask. How to
In
find
recursion, the time complexity is generally very high. So,
yeah.
I,
So yeah, we employ higher level methods like dynamic programming and all to reduce the time complexity. Like let me give like what we do here, like Fibonacci. consider the Fibonacci tree. As you can see that n equal to 2 comes here also and here also, and we are unnecessarily calculating this further, because if I have come to this, then I am like I have calculated this previously, right? So I am calculating this unnecessarily. Because if I can store the things like if I can store the value of n equal to 2 in some array or like that, then I can just pass this to this, right? I don't have to calculate this and this. I can just pass this value to this call. Same with this, n equal to 1. If I've calculated this, then I will just pass this to this. Don't I don't have to further calculate it. Same with 0 2. So yeah, we can store the values, and we can optimize a problem so that it can be done in order of n by recursion 2 if we just store the all the values, because every value can be calculated once only, right? If we have calculated once, then we don't have to go uh, and recalculate it once more. So every value is calculated once. So how many values are there? N values. So it's order of n. Don't go into this. Like this is a high level concept, dynamic programming. It's a wide paradigm of solving the problems. It's a difficult paradigm also. So yeah, uh, I think yeah, we can cover
Okay.
this sometime later if we get the time. So someone has asked how to find number of such subsets. You are talking about partition problem, right? So Rupari is not here. Okay. So yeah, you can just count like I was yeah, inputting like I was returning the variable check boolean variable. You can create the counter too, and like for every subset equal to 0, you can just increase the counter. So you will find the number of such subsets. Okay. So any more doubts? So yeah, let's end this class here. Uh, Hope to meet you guys in later classes also if we get the time. Okay. I hope you enjoyed the session and all. You understood all the things. So yeah, goodbye. Have a nice day.
Thank you for the session.
Thank you.